Good morning, math friends. Today we're going to talk about what are the different ways of displaying data. Now, when we talk about statistics, we're talking about data, information, and how we process it. Imagine you're doing a survey and you're asking everybody in the high school how many classes they are taking. You're going to have a lot of information. Everybody's going to give you an answer. The thing is, you need to be able to process that answer. Because if you then have to make a presentation explaining the number of classes people are taking in this high school, you can't just give out what everybody said. It doesn't mean anything. You need to be able to process it, to put it into something, to condense it into something that means something or that shows a trend, that shows something important about that data. So today we're going to talk about these different ways of showing the data. And we're going to do it by going through the different types of graphs and different types of ways we can display data one by one. So the first way we do it is using the bar graph. Now the bar graph is a great way to show categorical or qualitative data. Now what is qualitative data? It's data about categories, something that has a quality. So for example, favorite ice creams in LA is qualitative data because it has to do with chocolate, vanilla, strawberry, lemon. You're putting people into categories in terms of qualities of something, as opposed to quantitative data, which is data about numbers, where you're putting quantities to things. So the bar graph, you have the different answers people give and the number of people who gave that answer. So it allows you to see the frequency with which people said, I like chocolate, I like vanilla, I like strawberry, I like lemon. Now when you're drawing a bar graph, you need to remember that the bars need to have the same width, because you're trying to give people an impression of what people's tastes are compared to one another. And if you make the bars different widths, it gives a false impression of how different the frequency of people who like that ice cream is compared to another. So if I made chocolate really thin and strawberry really wide, you would have a false impression of what the difference is between the two are. So we try to keep them the same for coherence. The other thing you need to remember when drawing a bar graph is that there are spaces between the bars. This is specific to bar graphs, and it's how it is. And whenever you're drawing a bar graph, you need to make sure that that stays like that. Whenever you're drawing any graph, you need to remember that every axis has titles. So here you need to write what the categories are and the number of people, and that graphs in general have titles as well. The histogram. Now the histogram is a variation on the bar graph, but it's used for quantitative data or data with numbers. So here, for example, you have numbers. You're placing people into categories based on their height, but you can process height, you can measure height, you can take an average height. So this is numbers. Now again, the bars need to have the same width, and there is no space between the bars. And that's one way of differentiating a histogram from a bar graph, is because of the spaces. Like any graph, they need to have titles on the axes and a title in general. Okay, now the histogram has some advantages. It allows us to see the trend. For example, here we could fit a curve and it looks a bit like that to fit it. And we know that it's slightly skewed and we can see some things like that. However, we can't see each individual data point, which sometimes makes histograms very general, very vague. So there are other ways we're going to look at right now which allow us to see more each data point in particular. So now we have the stem and leaf plot, and the way a stem and leaf plot works is you have the stem in blue and the leaf in red. And the stem here, for example, is going to be the tens digit, and the leaf is going to be the units digit. So, for example, this is going to read as 1, 5, 5, 7, 9. And then here you have a 1 here, so this is going to be 10, 12, 12, 15, 17, 19, 19. And then 21, 22, 22, 25, 32, 35, and 43. Now, this plot is useful because it divides the data into categories, because we have categories of tens here. Here you have the units, then you have the tens, 20s, the 30s, and the 40s. But it also allows you to see each data point individually, because you can see exactly what the data is, but you can also see how many data points are in it, which allows you to fit a little curve and see the trend within the data. So this plot is very useful. However, it's very time consuming to make, and it requires you to have a small amount of data, because if you have like thousands and thousands of pieces of data, you can't put it into a stem and leaf plot. It's just too much. Okay, so next plot we're going to look at is the box and whisker plot. Now, the box and whisker plot allows you to see data based on how much data is within certain categories. So instead of seeing you have a category, how much data is in it, you're going to have, you have a certain amount of data, which categories does it fit in? Let me be more specific. You draw it because this is a minimum point, and this is the maximum point. And this is going to be the median. Now, if you don't know what the median is, you should probably go back and see our Introduction to Statistics and Probability video. Median means that there is 50% of the data here and 50% of the data here. Now, it's not, means that half the data points we collected are between these two lines here, and half the data is here. Here we have the first quartile and the second quartile, the third quartile, sorry, which means that 25% of the data is here, 25% is here, 25% here, and 25% here. So from this data, we can see that, for example, a lot of people lie between the 0 to 5 category here, because we can see that 25% of the data is condensed. That's a quarter of the data is condensed over that very short period. The same goes for here. 25% lies there. However, we can see that the last 25% here are spread over a much larger period. They're much more widespread out. From this, we can see a general trend. We can see skewness because we know a lot of the data is here and very few is there, although it spans out because the maximum is high. But again, it doesn't allow us to see each of the individual data points. Now, a more graphical way of seeing data would be the relative frequency distribution, or the frequency distribution. Now, the frequency distribution works because by having the test score here at the bottom and then the frequency at which it occurs on the y-axis there. And you can therefore see how many people got a particular score and see the general trend that it gives. It allows you to see each individual data point because it's graphed here on the graph. And so it's very useful to show patterns and trends while keeping the number of data points and staying very accurate. You can have a relative frequency distribution, which is when instead of having the total number of people, you're going to have it as a percentage. So for example, if you know that there are 200 students in this middle school, and you know that 100 of them got a certain score, instead of it saying 100 got X score, it'll say 50% gets X score. So that's the difference between a relative frequency and a frequency distribution. Okay, so I think we've covered a lot of the more common plots that we generally see when processing data. There are more, and we might discuss them later. But in the meantime, if there's one thing that I want you to remember, is that of all these different plots, they all have different strengths and weaknesses. And that whenever you want to present data, you need to choose the plot that is most appropriate for what you want to convey. Not the one that you see the most or the most common one or what everybody else is doing. The one that you think best conveys the general trend that your data is trying to say. Alright, thank you for watching. See you next time.